All right, last section. Only 5 questions. Yay, on electromagnetism. Okay. So we've got students investigating electromagnetic induction. So they've got a bar magnet, they've got a coil of wire, they're trying to measure current, which is most likely to be observed by the students. Okay, so remember, this is where we move a magnet through a coil of wire and we induce a current. Okay. So let's see what our choices are. We should have an induced current, so we could cross off D if we're moving the magnet through the coil. The current is going to be greater if the magnet is moved faster. That's one of the things that we learned. You could kind of see that in the little simulation we did, and then we also talked about it. So this one wouldn't be a good choice, and this one wouldn't be a good choice because the current's going to be larger. That's one of the things that makes a stronger electromagnet. So A, the induced current is larger when the magnet is moved quickly than when moved slowly. Okay, so stronger magnet, faster moving magnet, because that's a more changing magnetic field. Also, number of coils. All of those have like a direct relationship with the strength of the electromagnet. And I kind of just talked about all those. What are some ways to make an electromagnet stronger? Select all that apply. So add more coils of wire. That's one of our C's. Increase the voltage. That's going to increase our current. That's another C. Use a bigger nail. Use a larger core. So this was coils, current, and core. Reversing the poles of the magnet. It's not going to make it stronger. Going from AC to DC, no. Decreasing the current, definitely not. So these three are going to be your ways we make it stronger. What is true about electricity and magnetic fields? I think the best answer here is going to be that electricity always creates a magnetic field. So if we have a current, it creates a magnetic field. Moving flow of electrons creates a magnetic field. A permanent magnet has a magnetic field. Also, a temporary magnet has a magnetic field. You don't need electricity to create any magnet. There are magnets that occur. We talked about those elements, iron, cobalt, and nickel. Electricity is stronger than a magnetic field. I don't know about that. And then it prevents magnetic fields from occurring. Also, don't know about that. This one is our best answer here. What type of core is best for electromagnets? Of these choices, we're going to pick iron. Iron, cobalt, and nickel are our permanent magnet type elements. And then finally, what can you conclude from this graph? So this is a graph of number of clips attached versus current. Okay. Number of clips attracted. Sorry. So this is like how many staples we picked up. Okay, so that would be kind of the example here. So how many staples or little things did we pick up versus current? So we see that this graph is a linear increase. Okay, so there's definitely a relationship here between current and between our number of clips that we picked up. We see that as current increases, this number increases. So we could conclude that as current increases, magnetic strength increases. Okay. So they've got a direct relationship and it's a linear relationship together. And that's it for electromagnetism. Not too much to cover. And we just did it. So hopefully it's fresh in your minds.